Welcome back, everyone. In this video, I'll cover the disposability section of the 12-factor app. So let's get started. So maximize robustness with fast startup and graceful shutdown. So the disposability section is about maximizing robustness with fast startup and graceful shutdown. The 12-factor app's processes are disposable, meaning that they can be started or stopped at a moment's notice. This facilitates fast, elastic scaling, rapid deployment of code or config changes, and robustness of production deploys. Okay, so a 12-factor app's processes are disposable. So they can be started or stopped at any moment's notice. So this gives fast elastic scaling, and we can rapidly deploy code or config changes, and robustness of production deploys. So changes can be deployed to production also pretty fast. So at a high level, 12-factor apps processes should be disposable. That means they should be able to be started or stopped at a moment's notice. Processes should strive to minimize startup time. So processes should start pretty fast. I mean, they shouldn't take a long time to start up. Ideally, a process takes a few seconds from the time the launch command is executed until the process is up and ready to receive requests or jobs. So a process should take only a few seconds to start, and it should be ready to receive requests as soon as it starts. Short startup time provides more agility for the release process and scaling up. Yep. So you don't want, if the startup takes a long time, then yeah, basically the process that's coming up will not be able to handle traffic requests that are coming to it fast enough. So that's one reason the startup time should be really short. And it aids robustness because the process manager can more easily move processes to a new physical machine when warranted. Yeah, so it aids in robustness. So the solution will be much more robust if the process manager can move processes to a new physical machine. So let's say if you have 2 or 3 processes on a machine and one of the machine is running out of resources. When it's running out of resources, say when it's running out of resources, you want to move the process to a new physical machine. So you can easily move it to a new physical machine. Processes shut down gracefully when they receive a signal. Okay, so if a process receives a shutdown signal, they should shut down gracefully. A web process graceful shutdown is achieved by ceasing to listen on the service port, allowing any current request to finish and then exiting. Okay, so they're saying if it's a web process and it receives a SIG term, it should shut down gracefully. The first thing it should do is, because a web process is listening to requests, it should stop listening to requests and then allow any of the requests that are in the pipeline to finish and then exit. Implicit in this model is that HTTP requests are short, no more than few seconds. Or in case of long polling, the client should seamlessly attempt to reconnect when the connection is lost. So HTTP requests are typically pretty short, but in case there is a long request, then the client should attempt to reconnect when the connection is lost. For a worker process, graceful shutdown is achieved by returning the current job to the work queue. Yeah, so if it's a worker process and it's doing work, let's say it's compressing some images, or it's processing an image or a media file, typically that takes a long time. It's a worker process like that, and if it receives a sick term to shut down, then it should return the current job to the work queue. For example, on RabbitMQ, the worker can send a knack. So looks like, or on Beanstalk, the job is returned to the queue automatically whenever the worker disconnects. Okay. So looks like these two worker processes, if yeah, on RabbitMQ, the worker can send a knack, and then on Beanstalk, the job is returned to the queue automatically whenever the worker disconnects. Log-based systems such as delayed job need to be sure to release their lock on the job record. Okay. If it's a system like delayed job, they're saying it should release its lock on the job record. Implicit in this model is that all jobs are reentrant, which typically is achieved by wrapping the results in a transaction or making the operation idempotent. So basically in this model, anytime a worker fails to finish, it should be able to re-enter it as soon as the system starts up, or as soon as the app starts up or the process starts up again. If it's in the middle and it stops, then something should restart it. It should be like a transaction. If it can't complete fully, then it should roll back, and then something else, when the application starts back up or the process starts back up, it should re-execute the job. This should also be robust against sudden death in case of a failure in the underlying hardware. So they should be robust. Basically, they should, if there is someone pulls a plug, if someone pulls the plug, then it should be able to handle situations like that also. While this is much less common occurrence than a graceful shutdown with SIG term, it can still happen. A recommended approach is use of a robust queuing backend such as Beanstalk D that returns jobs to the queue when clients disconnect or timeout. Either way, a 12-factor app is architected to handle unexpected, non-graceful terminations. Crash-only design takes this concept to its logical conclusion. Let's see what crash-only design means. So to summarize disposability at a high level, disposability, a 12-factor apps processes should be disposable. So that means you should be able to start or stop at a moment's notice. So they should shut down gracefully if they receive a sick term. Even if there is a sudden death scenario, they should be able to recover from it. At a high level, to summarize, yeah, any 12-factor apps process should be disposable. Cool. So that's the summary of disposability. We'll go to the next one, dev prod parity, in the next video. I'll stop this video for now.